Welcome back, Algebros. Coming up next in our land of factoring, we're going to talk about how we do things that are not binomials and make them factor form. For instance, something that kind of looks like this form that you're seeing right here, x squared plus sx plus p, where s and p are real numbers. Don't worry too much about this notation, it's just a fancy notation for saying that s and p are numbers that are real numbers. Fancy math speak. Teach that to someone as a party trick. It's important to know that this won't work for every single trinomial you'll ever see. It only works whenever what we call the leading coefficient is 1. So when you look here at just x squared plus sx plus p, the coefficient on x squared is 1. We just don't see it. Whereas s and p are actually any real number. In other words, we're going from an expanded form, as is the form above you, to a factored form, which will be two binomials, as you've seen before. How does this look? It's actually a really fun trick, and one of my favorite ones in the quadratics unit, because it's a mixture of guessing and checking with a lot of your multiplication and addition skills. It's fairly simple, and then you arrive to an answer fairly quickly after. The steps? You want to find two numbers whose sum gives you s, in other words, s being the number that's attached to x, and whose product is p. So two numbers, who when you add them together, because sum means addition, you add them together to get s, and product, multiplication, you multiply them together to get p. I've got a little hint right here that says it's helpful to list factors of p and work from there. Once you have those two numbers, the factored form is just x plus the first number as your first binomial, and then x plus the second as your second. How does that look? Well, let's look over here at this one, x squared plus 5x plus 4. First of all, let's identify s and x. We know the general form is x squared plus sx plus p. So in this case, s is 5 and p is 4. Now the hint I gave you before is to list out the factors of p. More specifically, I want to list the factor pairs, or in other words, the numbers that multiply together to give you p. So for 4 could come from 1 times 4. It could also come from 2 times 2. But realistically, that isn't enough. We need to consider the negative possibilities, because it's very possible that the two numbers we're trying to find are negative. So in order to get a positive number from negatives, we need to multiply by double negatives. So in this case, I can also say that -1 times -4 gives me 4. And it can also be from -2 times -2. Now, in order to figure this out for the next step, we need to add those factor pairs. We did 1 times 4. Now let's see what happens if we have 1 plus 4. That's going to give me 5. 2 and 2 added together is going to give me 4. -1 and -4 is going to give me -5. And -2 and -2 is going to give me -4. Which one of these adds up to being s, which we found to be 5? You guessed it. It's 1 times 4, or 1 plus 4 in this case. Now, we found those two numbers. This entire thing was step 1. Now, we immediately write the factored form as x plus the first number into x plus the second number. Here, this is the setup for it, x plus something and x plus something. We know those numbers are 1 and 4, so it doesn't matter which order. 1 could go first, 4 second, or the other way around. Our factored form is x plus 1 into x plus 4. This might have seemed like it took a while, but eventually when you do more practice with this, you're going to build the intuition for what are possible values that are just impossible, and which ones are very likely to work. I'm going to see a few examples right here. The kind of instructions you'll get for something like this is factor the following expressions. So look out for that. Let's make these in factored form. Looking at the first one, I can identify that the thing attached to x is my s, that's 9, and the constant is p, my 14. Let's think of some factor pairs that give me 14. Obviously 1 in itself, and then 2 and 7. Since it's positive, we also need to consider the negative factors that give it. So negative 1 times negative 14, and then negative 2 times negative 7. Again, if you don't know how to find factors, remember some of the strategies you learned in 6th and 7th grade, including using a t-chart. But if you need extra help, you should come and find me, because you probably won't be able to do these as effectively unless you know how. Now let's look at those additions. You can probably look at some of these and think they're just straight up impossible out the get-go. Our sum is 9, which is positive. So it's unlikely, impossible, that negative combinations are going to give it. So negative 1 and negative 14 and negative 2 and negative 7 are definitely not the answers. That leaves 1 and 14, whose sum is 15, and 2 and 7, whose sum is 9, to work. In this case, we fortunately have 2 and 7 that work. So now I set it up. Remember the general format that it should go? X plus the first number into x plus the second number. So it's going to be x plus 2 into x plus 7. And now you have something that looks like those factored forms we've seen before. Let's dive into some negatives. X squared minus 2x minus 63. First of all, let's think of some factor pairs for 63 without worrying about the negative sign. We obviously have 1 and 63. Thinking through a lot of your rules, you're also going to have 3 times 21. And then finally, 7 times 9. I did these fairly quickly, but you can find it by creating a t-chart. Now, 63 is negative, so we need to consider the negative possibilities as well. Obviously, in order to get a negative number in multiplication, you need a positive times a negative. So these three factor pairs actually have two possibilities, where one number is negative, so negative 1 times 63, negative 3 times 21, negative 7 times 9. And now we're going to do them again, but this time the minus on the other number. So it's going to be 1 times negative 63, 3 times negative 21, and then 7 times negative 9. Now let's do the additions. Negative 1 plus 63 is just 62. Doesn't work. Negative 3 plus 21 is 18. Nope. Negative 7 times 9 is 2. But here, s is negative 2. This negative sign matters a lot, so this one actually doesn't work. However, if it were inverted, as in if it were negative instead of positive, then it would work. So here's how we adjust for that. Try doing the opposite one. If negative 7 times 9 didn't work, let's immediately look at 7 times negative 9. That's going to be negative 2. That one did work. A fancy little shortcut that you can use. So now we have our two numbers, 7 and negative 9. So it's going to be x plus 7. Then x minus 9. Because since this 9 is negative, and the format is x plus that number, the plus and the minus become just a minus. Here's a clever and cheeky trick. X squared minus 25. The constant term here is negative 25, which is just p. But there's no x term. When there's no x term, what that means is s is 0. Let's have a look at those factor pairs now, shall we? For 25, I can have 1 and 25, and 5 and 5. Since it's negative, we need to do the same thing we did in the previous question. A negative on each one. Negative 1 times 25, negative 5 times 5, and then 1 times negative 25, and then 5 times negative 5, which is actually the same, so we really don't have to repeat that. In this case, since s is 0, we're looking for numbers that are just opposites of each other, and that one's fairly easy to find. Negative 5 and 5 added together is 0. This is what I mean by using your intuition. Eventually, you're going to find a way to find these completely on your own, and just figure out, oh wait, that's a strategy, or oh wait, that's the easiest one. So it's going to be x minus 5 into x plus 5. Let's do one more together, and that's going to be x squared minus 7x plus 6. Here, s is negative 7, p is 6, p is positive, so now we're going to go back to what we did before. One set of positive factors and one set of negatives. 1 times 6 and 2 times 3. And then they're negatives, negative 1 times negative 6, and negative 2 times negative 3. Let's start summing them up and seeing which one will give us negative 7. 1 plus 6 is 7, so no. That one is the inverse of what we saw before for the s. So let's try the opposite one. Negative 1 and negative 6. That's negative 7. That one works. So open up parentheses, x minus 1 into x minus 6. There are 3 more at your disposal, and I'd like you guys to try these as you tries. We're at the end of the factor forest. How do you feel? Was it that hard? Can't imagine it was. I'll see you next week when we try our next skill, solving quadratic equations.